Coming to another topic, the domestic wastewater treatment, and we are discussing about the secondary treatment. In that, we discussed about the attached suspended growth culture and attached growth culture. Of course, the another one is the design of septic tank. Today we will design a septic tank. Coming to that septic tank, it is coming under the endobic tank because it is a closed one. So this septic tank is going to be designed for 500 students. Okay, here only they have given only 500 number. So whatever data is required, that data is to be assumed. What is the data that is required? Here I am assumed. Please you assumed. So the problem is the design is asked simply. They asked number of students or number of people is given. We are in the position to design the septic tank to required data to be assumed. You see here, I assumed here water supply equal to 135 liters per day per student. Sewage generation equal to 80% of the water supply. Sewage generation in the means the water is being used for the various purposes in the domestic in the residential buildings or commercial buildings. Therefore, because of that activities, obviously 80% of what is converted into the wastewater, the sewage. So therefore, that whatever water supply is given, that is multiplied with 80%, then it is equal to the that is nothing but sewage or the wastewater, domestic wastewater. So 80% of the water supply. Next, the detention time of the septic tank 24 hours. I assumed, of course, 24 to 48 hours they are taking, but I assume 24 hours. And the cleaning period, tank cleaning period once in a year. The sludge deposit, the human excreta or the activity solid matter, that is assumed 30 liters per year per student. 30 liters per year per student. Minimum freeboard. Once you find out the depth, above that we have to provide the freeboard, that is 0.5 meter. Length to breadth ratio, I assumed 4:1. That means the length is 4 times more than the breadth. 4 times more than the breadth. That is the we have to understand. Depth 1.8 meters. So this is the data is to be assumed for design of the septic tank for 500 students. We assumed required data. So first we have to calculate the total water supply. Coming to the total water supply generated. Total water supply total water supply required. Required, that is equal to so total water supply required equal to, we know that 500 students, for one student the water supply is 135 liters. Therefore you have to multiply it with 500 students into per person water supply 135 liters, so that equal to 67,500 liters per day. Okay. Next, total wastewater to be calculated, that is equal to 80% of total water supply that we assumed in the assumption, 80% of wastewater. So the 80% of the total water supply. So therefore the 80 by 100 because percentage, so 80 by 100 into total water supply 67,000 into 500, that is equal to 54,000 liters per day. Okay. Next, already we assumed detention time equal to 24 hours. So therefore the capacity of the tank required. Wastewater into detention time. Total wastewater equal to 54,000 per day. So therefore that is day, I convert into 24 hours into detention time 24 hours. Therefore these two get cancelled. So therefore once again you get 54,000 liters. 54,000 liters, so that converted into the meter cube, 54 meter cube. Okay, that is the capacity of tank required. Next, there is a sludge. The sludge is also to be added to the capacity of this tank. So therefore, we have to find out the sludge volume. Capacity required for sludge, that is equal. We assumed 30 liters per student per year. So therefore, that is the 30 liters per person per year into 500 students. 500 students, that is equal to 15,000 liters per year. Capacity of the septic tank equal to total wastewater plus volume of the sludge. That is equal to total wastewater. We got 54,000 liters plus volume of the sludge equal to 15,000. So therefore, the sum of these two equal to 69,000 liters. So that converted into the meter cube, we know that 1 meter cube equal to 1000 liters. So therefore, that is equal to the 69 meter cube. Next, the surface area of the tank equal to, now we got the volume of the tank. Surface area of the tank equal to volume of the tank divided by depth of the tank. The depth of the tank already we assumed 1.8. So therefore, volume of the tank divided by depth of the tank, that is equal to 69 meter cube divided by 1.8 meters. So if you simplify this one, we get 38.333 meters square. That is the surface area. Here we assumed already length into breadth ratio, that is equal to 4:1. 4:1. That means length is 4 times greater than the breadth. Breadth 4 times greater than the breadth. So therefore, let us assume breadth equal to B. Breadth equal to, let us assume B. So therefore, length equal to 4 into B. 4 into B. If you multiply this one, you can get the surface area 4B into B, that is equal to 4B square. This is the surface area, that is equal to 38.333 meter square. If you calculated B from this, B equal to root of 38.333 divided by 4. If we simplify this one, we get 3.1 meter. Okay. Therefore, we got now breadth, that is equal to 3.1 meter. So therefore, we can calculate length. Length equal to 4 into B. So therefore, 4 into 3.1, that is equal to 12.4 meters. Okay. Next, total depth of the tank, that is equal to, we assumed 1.8 and freeboard is also assumed 0.5 meters. Therefore, if you want to get total depth of the tank, we have to add this depth and assumed depth and freeboard. So therefore, that equal to 2.3 meters. So 2.3 meters. So therefore, the total dimensions total tank dimensions are L equal to 12.4 meters, B equal to 3.1 meters, D equal to 2.3 meters. 3 point meters. I have shown a simple diagram. So here this is the rectangular tank. Let us assume this is the length, this is the breadth, this is the depth. Thank you.